Welcome to video lesson 11.1 on direct and inverse variations. In this section, you're going to learn how to write and graph direct and inverse variation equations. Direct variation is when two quantities show direct variation when y equals some constant times x, where that constant is not 0. Okay. So an example would be like y equals 3x, okay, where 3 is your constant, so that would be your slope, okay? There's no y-intercept, so it's going through the graph right at 0, 0, okay? And it can either be a positive constant or a negative constant. It just can't be 0. When it's a positive constant, you can see we have this line here when k is positive, okay? And when it's negative, we have the second line here, right? Now, the one way to figure out whether two quantities show direct variation is if you take the ratio of them and divide them, that ratio is constant. So y divided by x is constant. That will show you have a direct variation. Now, the opposite of that would be inverse variation. And that is in the equation of the form y equals, it's also written like this, k divided by x. Again, k cannot be 0, okay? And all the more important this time because x can also never be 0, and that's why we don't have anything ever going through the point 0, 0, or even any points ever at x equals 0, because in math, you know, you can't divide by 0. So that's how we get this neat looking graph that has two curves in opposite situations. When k is a positive value, your curve is here in the first and third quadrant. When k is a negative value, your curves are outward in the second and fourth quadrants. Okay, and to know whether two quantities show an inverse variation, the product of them will be constant. Okay, so direct variation, the quotient is constant, and inverse, the product is constant. Okay. Now in example 1, we do want to know whether in this table it shows x and y being direct variation, inverse variation, or neither. And we need to explain our reasoning. So we know if we do y divided by x, okay, 5 divided by 1 equals 5, 10 divided by 2 equals 5, 15 divided by 3 equals 5, and 20 divided by 4 equals 5. So every time we take y divided by x, we get the constant 5, okay? And that means that this is a direct variation. Okay, since y divided by x is always the constant 5, every time. Okay? Now here, we want to get x and y related to each other. Okay, so what we're going to first do is divide each side by 4. Okay, and then we get x times y equals -1. Then we're going to divide by x. And we get y equals 1 divided by x. Now that's in the form y equals k divided by x, where now k is 1, of an inverse variation. So inverse variation, where k equals 1. All right. Now in example 2, they're telling us that y varies directly with x. And when x is 12, y is -6. Now what we have to do is we have to write a direct variation equation, and then we have to graph that equation. Okay. So first thing we need to do is find the value of k. What is that constant that we're using here? So we know a direct variation equation looks like this. Okay, now we're going to substitute in what we know. When x is, or when y is -6, x is 12. So we'll divide by 12. So k equals -1/2. Now that equation will be y equals -1/2 x. Now we just need to graph that. Okay. So when we graph that, we know the y-intercept is 0. Okay. And then the slope is negative 1/2, so that means we're going down 1 over 2, down 1 over 2, likewise up 1, left 2. Okay, and then we can just graph that. And that's our equation of y equals negative 1/2 x, our direct variation equation. When x is 12, y is negative 6, we found k, and then we wrote the equation and graphed it. Now, a little bit trickier is when we're graphing an inverse variation equation because we're not used to actually graphing those. All right, so we need only one ordered pair because we can use this ordered pair to find k, right? And let's write what we know for the direct variation equations, okay? That's the form of an inverse variation equation. That's the form of the inverse variation. And now let's substitute in the values we know. So we know 5 is y, we don't know k, and we know x is 2. Now to get k by itself, we're going to multiply each side by 2. So k equals 10, and now we'll just rewrite that. So y equals 10 divided by x. Okay, and that's our inverse variation equation, excuse me. Now, in order to graph inverse variation equations, it's best to make a table of values, okay? We know from looking at the first page of the notes that inverse variation equations, when the k is positive, okay, we're going to have curves in both the first and the third quadrant, okay? When k is negative, which is not in this case, we would have curves in the second and the fourth quadrant. Now we just have to kind of find out where they are. Okay, so we can't ever have x be 0 because there's no values for y then because it would be undefined at that point. Okay, so we can just pick some values, negative 10, negative 5, negative 2. We can do 0, but it's going to be undefined there. Okay, 2, 5, and 10. Whatever we do negative, we'll want to do the same values positive to really get our curve well. Okay. And 0, because we can't divide by 0 in math, that's undefined. Okay. 10 divided by negative 10 is negative 1. Okay. 10 divided by 10 is 1. All right. And 10 divided by negative 5 will be negative 2. And 10 divided by negative 2 is negative 5. 10 divided by 2 is positive 5. And 10 divided by 5 is 2. Okay. So, now we'll just graph those points. 1x is negative 10. Right here we have negative 1, negative 5, 9, 8, 7, 6, 5 is negative 2. Negative 2 is negative 5. 2, 3, 4, 5. And we don't have a 0 value. Okay. So we have this kind of curve here going like this and coming down here. Okay, but we never intersect the y-axis because we never have values when x is 0. Okay, so 2, 5, okay, and 2, 3, oops, that was 2, 5, I graphed 1, 5. Sorry about that. 2, 5, 1, 2, 3, 4, 5, and 5, 2, and 10, 1. And so this one is like this. Okay? And now we've graphed the inverse variation equation of y equals 10 divided by x. Now in example 4, it says which situation represents, sorry, this should have been example. Why did I put 4 there? 2, sorry about that. We do have example 4. We just don't have example 5 in this. Sorry about that. Example 4 says which situation represents inverse variation. So we're buying several movie tickets for $7.50 each. All right. What that would mean is, so A would be 1 movie ticket is $7.50. 2, then we're going to add another $7.50 to $7.50, so that's 15. 3 is then $22.50. Okay, so if we take y divided by x, it's always going to be constant. Okay, so that's direct variation, not inverse. So we know A is not it. B, we earn 50 cents for each pound of aluminum cans we recycle. Sorry, that should say recycle, not whatever that word is. Okay, so recycle. Couldn't type apparently. Sorry about that. And that L should be still there, but my smartboard's a little bit off. Okay, we'll just rewrite this whole word. Recycle. All right. So 50 cents for each pound. So if we have 1 pound, 50 cents, 2 pounds, $1, 3 pounds, 150. And in either case, if we take y divided by x, we're going to get 50 cents. So since y divided by x is constant, that's also direct variation, not inverse. How about C? The cost of a $600 cabin rental is shared equally by a group of friends. So if we had one group of friends and we shared it equally, well, one person would be paying all $600. 2 groups of friends shared equally would only be paying $300. 3 groups of friends would only be paying $200. In any case, the product, okay, x times y now, is at a constant $600. So this would be an example of an inverse variation, which is all we need. Okay, and we can double check. D is again, songs are 99 cents each. So we'll have, no matter how many we take y divided by x, it's always going to be the constant of 99 cents. So that's also direct. Okay, and so C is the inverse variation. Now we have some practice problems here. Do your best. Make sure you write down any questions that you have so we can answer them during class. And have a great day.